Gattuso et al. In 1998 showed that the increase of calcium carbonate saturation rate from 98% until 390% can enhance calcification rate nearly 3 times. But the increase of calcium carbonate saturation until 585% did not affect on coral calcification. Marivini et al. In 2008 showed that acidification effect on coral calcification by decreasing the availability of carbonate for calcification. Unlike carbonate ion, the increase of carbon dioxide and bicarbonate in seawater has negative effect on coral calcification and their crystalline structure. The increase of uptake of carbon dioxide by ocean reduces pH, and we can see the same result about increase of bicarbonate ion concentration. But there are only few studies on the direct effect of bicarbonate on coral calcification. These studies emphasize that with increase of bicarbonate, the availability of carbonate ion decrease. In fact, both of them, bicarbonate and CO2, led to reduce in coral calcification. In fact, both of them involve in the ocean acidification by decreasing the pH through increase of hydrogen ions. Now we want to see how alkalinity change can affect on crystalline structure in the corals. In order to understand the crystalline structure response in scleractinian corals to environment change, we need to be familiar with two fundamental units in coral skeleton: center of calcification and coral fibers or crystallites. Coral fibers are tiny aragonite crystal structure with diameter 0.04 until 0.05 micron. They make three-dimensional form in the coral skeleton. They assemble as a spherulitis form and they are gathered into the fish head-shaped bundles. The fibers grow in a vertical spin form called turbacula, and a number of turbaculas create coral septa. Centers of calcification are located in the middle of each spin, and they are granular submicronic crystals grouped in 2 until 4 micron nuclear packets within the centers that provide a scaffolding for the further growth of the fibrous skeleton. In some paper, they call it as a Li mineralization zone, EMZ, but it is common most of the paper we call them centers of calcification. Let's show you here the center of calcification and coral fibers. In this picture you can see the Favia Stalagera coral leads with different resolution. The picture number 1 is coral lead that we can see with eyes easy. But if you try to watch the septa with more resolution with electron microscopy, you are able to realize coral fibers and center of calcification. If I want to explain better, in the septa, these dotted rectangles show to us the spin which they made from turbacula collections. And with more resolution you can see fibers and centers of calcification inside of each spin. In fact, turbacula is collection of center of calcification and coral fibers. And as you can see in this picture ABC, center of calcification and coral fibers are different form in different species, and environmental parameter changes such as dissolved inorganic carbon can be led to different form in one species. This is another picture just to see the center of calcification with more resolution. As you can see the granular crystals package in the centers that they are provide a scaffolding to grow of fibers. During the coral growth, the crystal fibers are made by adding a few micron thin grow layers. Furthermore, the change in the physico-chemical parameter of seawater affect coral biomineralization cycle. Thus, each grow layer in scleractinian coral can represent the actual environment recording unit. In fact, any change in the chemistry of seawater in reef environment can affect in the chemical structure and form of coral fiber and center of calcifications. Before I start to talk more about effect of dissolved inorganic carbon on coral crystal structure, I need to say there are just a few studies about different part of dissolved inorganic carbon on coral crystalline structure, and most of the papers about this are new and they published from 2015 until 2017, and of course they publish it in the good journals like Nature and Science. Anyway, we just started to understand scleractinian coral structure response to environmental parameter change. One of the good examples of this researcher is Foster et al. In 2016. Foster et al. Studies the crystalline structure in juvenile of Acropora spacifora in the high PCO2 900 microatm and temperature almost 27 centigrade. They realized that the increase of CO2 in seawater caused in reduction in overall mineral deposition in the coral skeleton and also a deformation and porous skeleton structure in the coral. This is because of coral fiber and center of calcification are grow with low density and also different form. In fact, Foster et al. They provided 4 different environment control with temperature 24 and 250 micron atm PCO2 and pH 8.2 and environment with high temperature with 27 centigrade and 250 micron atm PCO2 and pH 8.2, and also environment with high amount of PCO2 with temperature 24 centigrade and 900 micron atm and pH 7.7, and also environment with high temperature and high CO2. The temperature was almost 27 centigrade and CO2 it was 900 micron atm and pH it was 7.7. As you can see, the calcium carbonate structure in these 4 environments has huge difference. The mineral deposition and carbon and skeleton form in the environment with high temperature and CO2 is completely different from others. Abnormal carbonate calcium structure in the environment with high temperature and pressure CO2 is visible. Another interesting thing is this: high PCO2 has more effect than high temperature on coral skeleton, and when both of them join together we have more abnormal structure and porosity and low density in coral skeleton. This another excellent study. It is about the effect of alkalinity change on coral crystalline structure. I think this is the best one that he answered the most of my question. This research it's published in 2015 in Nature groups, and he studied the morphological change of coral skeleton under alkalinity change. He used 4 different pH, carbonate, bicarbonate, PCO2 and saturation state rate. He showed that high CO2 and bicarbonate ion, which is result of ocean acidification, is not only the case of decrease in the calcification rate per month, but also it case the morphological change of coral skeleton. He showed that the environment with low pH and low carbonate ion is case of more porosity and potentially fragile phenotype. The same things which Foster and et al. Showed to us. We talked to you what will happen if we have low pH, I mean in the low amount of carbonate ions and high amount of bicarbonate and CO2, we have very fragile and deformed carbonate calcium structure in skeleton of corals. But now I want to show one good example to know what will happen if we have high pH and calcium carbonate supersaturating rate.